How does the volume of a 40 decibel sound compare to the volume of a 20 decibel sound? Now I think one of the easiest ways to answer this question is to put 30 decibel sound in the middle. We know that if we increase the volume of something by 10 decibels, it's 10 times louder. So if we go 20 decibels to 30 decibels, then the 30 decibel sound will be 10 times louder. And if we go from 30 decibels to 40 decibels, then the 40 decibel sound will be 10 times louder than the 30 decibel sound. So 30 is 10 times louder than 20, and 40 is 10 times louder than 30. So how many times louder is 40 than 30? Well, the answer should be pretty obvious. If 40 is 10 times 30 and 30 is 10 times 20, then 40 must be 10 times 10 as loud as 20. So that means that our answer is not twice as loud as you might expect if we had a linear scale, and not even 20 times as loud, but 100 times as loud. This is because decibels work on a logarithmic scale. If we get something that's 20 decibels louder, then it's 10 to the power of 2 times more intense. Question 12. Match the volumes to the sound sources. Now let's take a look at these. We have 60, 70, 80, and 100 decibels. We have 4 different events: a vacuum cleaner, a jackhammer, normal conversation,
of course, it was impossible to
and a freight train. So we know that vacuum cleaners are probably going to be louder than conversation, which is likely to be the softest one here. But they're not as loud as a jackhammer, of course, and they're probably quieter than a train, even if that train is 15 meters away. So we can match a vacuum cleaner to 70 decibels. The 2 loudest ones over here are probably the freight train and the jackhammer, but the jackhammer is at a distance of 1 meter, and the freight train is at a distance of 15 meters. So in this case, the jackhammer will probably be much louder, and we can assign that to the 100 decibels. Normal conversation is going to be the softest of these. It tends to be at about 60 decibels, although of course that may vary depending on how loud you talk. And finally, the freight train will be left with 80 decibels. Question 13. Calculate the volume of a sound that is 10 times louder than a 24 decibel sound. Now, can you remember how the decibels work? If we add 10 decibels, then we increase the intensity by a factor of 10. So if we want to be 10 times louder, that is 10 times more intense, then all we need to do is add 10 decibels. So a change in 10 decibels corresponds to something 10 times louder. We end up with a sound that is 34 decibels. How about 10 times softer than a 9 decibel sound? Well, if we want to get 10 times softer, all we need to do is subtract 10 decibels, right? So 9 minus 10 is, oh dear, we've got a negative number. But remember, this is okay. Negative numbers are fine. 0 decibels is simply defined by the limit of human hearing. If something is less than 0 decibels, then humans can't hear it, but that doesn't mean that it doesn't exist. If, for example, we had more sensitive ears, or if we had, for example, a pet that could pick up on something of that volume, then they may be able to hear it. Question 14. A certain 800 Hz sound is 8 times louder than another 800 Hz sound. Now, because the frequencies are the same, we don't need to worry about how they affect the volume. The sound is 8 times louder than the other sound. By what factor is its amplitude greater? Now, how does amplitude affect intensity? Well, we learned right back at the beginning that if we double the amplitude of a sound, then we quadruple the intensity. That is, the intensity is proportional to the square of the amplitude. So that means that if we square the change in amplitude here, we'll end up with 8. Well, 8's not a square number. What's our answer? Well, if it's 8 times louder, then its amplitude is the square root of 8 times greater. We can of course simplify this using a calculator to 2.83. The amplitude of the sound is 2.83 times greater, and if you square that using a calculator, you'll get a number that will tell you that it's very close to being 8 times more intense. Question 15. Does a sound with higher volume always sound louder to us? Now think carefully before you answer. The trick here is that we have to worry about whether it sounds louder to us. Remember that the human ear is not equally sensitive to all different frequencies. So the human ear will have different sensitivities to different frequencies, which means that sounds with higher volume do not always sound louder to us. Sounds are most sensitive to the frequencies of ordinary conversation.
Commencement from one of the finest universities.
it is about 3 to 4 kilohertz, and they're less sensitive as we move further away from these frequencies. In fact, if we move below about 20 hertz or above 20 kilohertz, sounds will be completely inaudible. So that means that regardless of how high the volume of an infrasound or of an ultrasound is, we won't be able to hear it. Question 16, bit of a bonus question. If 10 decibels correspond to a tenfold increase in volume, then how many decibels correspond to a twofold increase? That is, how many decibels do you need to increase by in order to get the volume of a sound doubling? Now this is a bit of a tough question. The first thing that we should do is find an equation that shows how the intensity of a sound changes with decibels. Now we know that if we add 10 decibels, then we'll increase by 10 times. And if we add 20 decibels, then we'll increase by 100 times. We add 30, we'll get 1,000. So what we're doing is we're taking 10 and we're raising it to the power not of the number of decibels, but by 1/10 of the number of decibels. If we have 10 decibels, we'll have an intensity of 10. If we have 20, we'll have an intensity of 10 to the 2, 100. If we have 30, it'll be 1,000, and so on. Of course, we need to have a starting point as well. So we'll call that I0. So that means that the intensity of a sound equals I0, the original intensity, times 10 to the power of the increase in decibels over 10. And this will give us an equation for how intense the sound is. Now, if we want to find an increase of a factor of 10 or by a factor of 2, then we should divide both sides by that I0. So that means that if this is a factor of 10, then we need this whole thing to be 1. So x over 10 needs to be 1, so x is 10. If we want the increase to be 100-fold, then we need it to be 10 to the power of 2. So x over 10 is 2, x must be 20. So an increase of 20 decibels will be a factor of 100 in the intensity increase. So in general, we can write down this equation. I over I0 equals 10 to the power of x over 10. Now, what if we want an increase of 2, or a factor of 2, so that we double the intensity? That means that the left side of the equation will be 2. So 2 equals 10 to the power of x over 10. Now this is going to be a bit tough, isn't it? Probably the easiest way to do it is with guess and check. Just try different values of x, it's going to be less than 10, until we figure out a number that's very close to 2. But in fact, there's a whole branch of mathematics that deals with questions like this, and that's called logarithms. But it turns out that using logarithms, we can say that x over 10 equals the log base 10 of 2. I mentioned before that if we take the log base 10 of, for example, 1,000, then we'll get the number of zeros in 1,000. It's like saying 10 to the power of 3 is 1,000. In this case, though, we don't have a nice power of 10 that we're taking the logarithm on. We have a 2. So we're going to need to solve this with a calculator. Before we do that, though, we can multiply both sides by 10, make it a bit easier for ourselves. And it turns out that there are a whole number of rules and identities that we can use with logarithms, but we don't really need to get into those right now. If you use the log button on your calculator, by default it's set to log base 10. There's another log button called ln, which means the natural log, but that has a base that isn't 10. You'll learn a bit more about it later. So if we take the log base 10 of 2 and we multiply it by 10, then we get a number of 3.01. So that means that if we increase the number of decibels by 3.01, then we double the intensity of the sound. If you want, you can check this by substituting into this equation here. Now 3.01 is a bit of an approximation, but you should get a number that is very close to 2, which means that increasing the volume of a sound by 3.01 decibels will double its intensity, assuming its frequency doesn't change. So with that sojourn into advanced mathematics, we'll finish. So that means we've finished the questions now. We've talked about the amplitude and intensity of sound waves, how loud they appear, how we measure sound, and the sensitivity of the human ear and how that affects the sounds we hear.